Drones have become an essential part of our lives, ranging from hobbyist activities to professional applications such as aerial photography, industrial inspections, and even emergency response. However, regardless of their purpose, ensuring a safe and successful flight begins with thorough pre-flight checks. By conducting these checks, you can verify that all drone components, including motors, propellers, flight controllers, and batteries, are in optimal condition. Assess weather conditions and environmental risks that could impact flight stability and performance. Ensure compliance with legal regulations such as no-fly zones, altitude restrictions, and necessary permits. Skipping or rushing through pre-flight checks can lead to technical failures, loss of control, or even accidents that could endanger people and property. A well-prepared drone operator takes the time to carefully inspect the aircraft and its surroundings before every flight. In this training, you will learn how to perform each critical step in a systematic and efficient manner. By adopting these best practices, you will not only protect your drone from potential malfunctions but also enhance flight safety for yourself and those around you. Remember, a few minutes spent on pre-flight checks can prevent costly mistakes and serious risks. In this module, we will cover the essential topics that ensure a safe and efficient drone operation. First, we will discuss regulations and guidelines, where you will learn about the legal requirements and rules that govern drone usage. Understanding these regulations is crucial for avoiding penalties and ensuring compliance with aviation authorities. Next, we will explore UAV systems and the technical aspects of pre-flight inspections. This includes checking critical drone components such as motors, propellers, flight controllers, batteries, and sensors to ensure they are functioning correctly. Then, we will examine weather conditions and how they impact drone flights. You will learn how to assess factors like wind speed, temperature, visibility, and precipitation to determine if the conditions are suitable for a safe flight. Another key topic is flight planning, where we will discuss how to create effective flight routes, utilize GPS technology, and leverage mapping software for accurate navigation. Finally, the core of this module will focus on pre-flight checks. We will go through a structured, step-by-step process to ensure that your drone is fully prepared for takeoff. By mastering these checks, you will significantly reduce the risk of technical failures and improve overall flight safety. Now, let's begin by exploring each of these topics in detail. Ensuring compliance with legal regulations is a fundamental responsibility for every drone operator. In this section, we will explore the legal framework that governs drone usage and the key rules that must be followed. In Turkey, the Civil Aviation Authority, SHGM, mandates that all drones weighing more than 500 grams must be registered in the SHGM system. This ensures that drone operations are monitored and regulated for safety. Additionally, flight permissions are required for certain areas. If you plan to fly your drone in city centers, near airports, or in security-sensitive locations, you must obtain special authorization from SHGM. Flying in these areas without the necessary permits can result in legal consequences. Another important regulation is the altitude limit. Without special permission, the maximum allowed altitude for drone flights is 120 meters. This restriction helps prevent interference with manned aircraft and ensures safe airspace management. Beyond national regulations, it is also important to understand the rules established by international aviation authorities, such as the FAA in the United States or other local institutions in different countries. Adhering to these regulations ensures that drone operations remain legal and safe. Lastly, drone pilots must be aware of no-fly zones, including areas near airports, military bases, and other security-sensitive locations. Flying in these restricted areas poses serious safety risks and can lead to legal penalties. By understanding and following these regulations, you can ensure that your drone operations are both legal and safe. Performing a UAV systems check before every flight is a crucial step to ensure safe and efficient drone operation. By carefully inspecting all technical components, you can prevent mid-flight failures and enhance overall performance. Start by examining the motors. Ensure that they are free of dirt or debris that could obstruct movement. Power on the drone briefly and listen for any unusual sounds, such as grinding or inconsistent operation, which may indicate internal issues. Overheating or reduced power output could signal a potential failure. Next, inspect the propellers as they directly affect the drone's stability and control. Look for cracks, bends, or signs of wear that could impact flight performance. Even a small crack can cause turbulence and reduce efficiency. Additionally, ensure that the propellers are securely attached and do not wobble during rotation. One of the most critical aspects of propeller inspection is verifying the correct propeller orientation and direction. Drones typically have two clockwise (CW) and two counterclockwise (CCW) propellers. Incorrectly installed propellers can cause the drone to become unstable or fail to lift off properly. Refer to your drone's markings or manual to confirm that each propeller is installed in the correct position. The battery should also be thoroughly checked. Confirm that it is fully charged, securely inserted, and free from any damage, such as swelling, leaks, or corrosion. A compromised battery can lead to sudden power loss and a potential crash. Always check the battery connectors to ensure they are properly attached. Now, move on to the sensors and cameras, which are essential for navigation, stabilization, and obstacle detection. Clean the lenses and sensor surfaces to prevent dirt or smudges from affecting performance. Ensure that all mounting points are tight and that there are no loose connections. Lastly, inspect the flight control systems and connection points. Secure all cables, antennas, and communication links, as any loose connection can lead to signal loss, GPS malfunctions, or unstable flight behavior. Ensure that the remote controller is properly paired with the drone and that there is no interference in the communication system. By conducting these detailed pre-flight inspections, you can significantly improve your drone's reliability and flight safety. Proper maintenance and attention to technical details will help prevent in-flight issues and ensure smooth, controlled operation. Understanding weather conditions is essential for safe and efficient drone operations. Various environmental factors such as wind speed, rain, temperature, and visibility can significantly affect your drone's performance and flight stability. Wind speed is one of the most critical factors to assess. Strong winds can cause instability, reduce flight control, and drain the battery faster. Before taking off, check your drone's wind resistance specifications and compare them with current wind speeds. Sudden gusts or turbulence can make it difficult to maintain control, especially at higher altitudes. Rain and humidity can also pose serious risks. Most drones are not waterproof, and exposure to moisture can damage internal components such as motors, batteries, and electronic circuits. If rain is expected, it's best to postpone the flight or use protective measures such as waterproof casings if available. Temperature affects battery performance and drone efficiency. In cold weather, battery life may decrease significantly, leading to shorter flight times. Extreme heat, on the other hand, can cause the drone's electronics to overheat, affecting flight stability. Always monitor temperature conditions and adjust your flight duration accordingly. Visibility is another crucial factor. Fog, heavy clouds, or low light conditions can reduce your ability to see and track your drone. Poor visibility also affects sensors and cameras, making navigation and obstacle detection more challenging. Flying in such conditions increases the risk of losing control or crashing. To ensure safe flights, pilots should utilize weather forecasting tools. Applications like Windy and UAV Forecast provide real-time weather updates, including wind speed, precipitation levels, and temperature forecasts. These tools help drone operators assess risks and determine whether conditions are suitable for flying. By carefully evaluating weather conditions before each flight, you can minimize risks, protect your drone from damage, and ensure a smooth and safe operation. Proper route planning ensures a safe and efficient flight. Use GPS mapping software to create a clear and structured flight path. Consider obstacles, wind direction, and your destination to avoid unexpected hazards. Wind can impact stability, so plan routes that minimize resistance. Always prepare alternative routes in case of emergencies like signal loss or sudden weather changes. A well-planned flight path improves efficiency and reduces risks, making your drone operations safer and more reliable. This slide summarizes the performance of quadcopter and tricopter drones under identical conditions. We compare key metrics: weight, power consumption, and stability. Quadcopter drones tend to be more stable but heavier and consume more power, while tricopters may be lighter and more agile. Evaluate these differences to select the best option for your needs. This slide compares lift capacity, flight time, maneuverability, and cost for quadcopter and tricopter drones under the same conditions. Quadcopter drones typically offer higher lift and longer flight times with robust stability, while tricopters often excel in maneuverability and cost-effectiveness. Evaluating these performance values helps you choose the best drone for your specific needs. In summary, comparing the performance of quadcopter and tricopter drones under identical conditions reveals distinct advantages for different applications. Tricopters are ideal for lightweight designs, offering extended flight times and being budget-friendly, which makes them perfect for hobby projects. In contrast, quadcopters provide enhanced flight stability, are better equipped for carrying heavier payloads, and are more suited for professional applications. Ultimately, your choice should reflect your specific needs, mission requirements, and budget. Thank you for your attention, and may your flights be safe and successful.